Because roads are not always perfectly straight and smooth, a good suspension is needed to smooth out these abnormalities, which also gives the rider a comfortable ride. In PhD 108, we discussed how the front forks operate under various loads and conditions. The program also explained the maintenance procedures that must be used in order to keep the suspension working properly. The front suspension on the Sportster model has changed little since the bike's introduction in 1957. But in 1995, Harley-Davidson Motor Company introduced the Sportster 1200 Sport. This bike suspension was designed from the ground up. It features cartridge-style front forks and nitrogen reservoir shock absorbers that have adjustable compression and rebound damping and spring preload. The rear suspension has a nitrogen canister piggybacked to the shock absorber. Compression and rebound damping as well as spring preload can be adjusted on this suspension. The suspension components, in combination with the 1200cc engine, make the Sportster Sport one of the most responsive bikes in the Harley family. In this program, we will explain the operation and service procedures for the new Sportster Sport suspension. The fork and rear shock absorber are designed to absorb bumps and other uneven road surfaces. This is accomplished by using springs, air, and oil. Let's identify the components that make up the new Sport fork. The three main components that make up the fork are the fork tube, slider, and damper cartridge. As we look at the cross-section of the fork, we can see that the inside is filled with about 2/3 oil and 1/3 air. The mainspring inside the fork tube has progressive windings at the bottom. The spring is held in place by two spacers, a spring collar, and a fork cap with an O-ring. This is used to seal out dirt and keep the air and oil in. The dust cover and seal provide the same protection for the slider tube. The seal is supported by a spacer. A retaining ring holds the seal in place. Two bushings inside the slider act as bearings, so the fork tube can easily move inside the slider. The damper cartridge is bolted to the bottom of the slider tube. The top of the cartridge supports the spring. A piston with a nylon ring separates the upper and lower chambers within the cartridge. Integrated with the piston is a two-way valve. This valve controls the oil flow between the two chambers. At the bottom of the cartridge tube is a compression valve assembly. This valve assembly also has a two-way valve, which allows oil to pass out of the cartridge during compression and prevent cavitation during rebound. At the bottom of the slider tube is the lower stop, which prevents the fork from bottoming out. Next is the compression adjuster, which controls the oil as it flows from the damper cartridge to the slider. The last components making up the fork assembly are the preload and rebound adjuster. This adjuster is made up of four distinct parts. The fork bolt screws into the top of the fork tube and is also the carrier for the spring adjuster plate. Next is the spring adjuster bolt. This, in combination with the adjuster plate, compresses or decompresses the spring for preload adjustment. The rebound adjuster fits inside the fork and spring adjuster bolt, and the complete assembly attaches to the top of the damper rod. The main spring controls the height of the bike while riding. When a bump is encountered forcing the slider upwards, the spring absorbs the force by storing the energy and then forces the slider back down. In this section, we will discuss how the new Sport fork functions. There are 3 compartments in the fork assembly. The first one contains mostly oil, with about 6 inches of air at the top. The smaller area in the top of the damper cartridge contains only oil. The rebound piston inside the cartridge separates the top of this compartment from the bottom. As the fork is compressed, oil is forced out of this compartment through the compression valve and flows out to the slider tube. Since a limited amount of oil can exit through this valve, oil also exits through a small hole at the bottom of the damper. The oil then travels through the Allen head screw and continues through an adjustable valve. This valve regulates the amount of compression damping by restricting the oil flow between the outer chamber of the slider tube and the inside chamber of the damper cartridge. The oil then passes through the 4 holes in the lower fork stop and continues into the fork tube. To prevent cavitation in the upper chamber, oil is also forced up through the check valve into the upper chamber. The fork rebounds or extends itself when spring pressure forces the damper cartridge and fork tube back to its original position. As this occurs, the chamber at the top of the damper cartridge gets smaller, and oil is forced out through the 2-way valve in the rebound piston and through the 2 small holes near the bottom of the damper rod. The oil continues up the rod and past an adjustable valve, where it exits into the slider. The bottom of the rebound adjuster has a brass needle that fits into a round opening at the top of the damper cartridge rod. When the adjuster is rotated clockwise for a stiffer setting, the needle begins to close off the opening and limits the amount of oil exiting the damper cartridge, resulting in greater damping. When the adjuster is rotated counterclockwise for softer rebound, the needle is backed out of the opening. The oil is allowed to exit the cartridge at a faster rate because of less restriction. This allows the spring to extend the fork at a faster rate. If the fork should top out or become fully extended, the rebound spring in the top chamber of the damping cartridge cushions the impact. During maximum compression, a small amount of oil is trapped between the slider and lower stop, which prevents metal-to-metal contact. Next, let's look at the rear suspension on the 1200 Sport. The rear suspension on the Sport model features a shock absorber that has a gas canister piggybacked near the top. This type of shock absorber is usually found on performance street and dirt bikes and is called the reserve tank type. The consistency of damping can be affected by the oil capacity and temperature within the damper. Because the gas chamber is a separate component, the shock body can be entirely filled with oil, allowing more consistent temperatures and damping. This reservoir is connected to the damper by a passage that allows the oil to flow between both components. A rubber bladder is used within the reservoir to separate the nitrogen gas from the damper oil. This prevents the two from mixing, causing a symptom called aeration that creates foam and makes the damping action erratic. The compression damping adjustments are controlled by an adjustment knob mounted on the top of the reservoir. Turning this knob clockwise moves the needle valve into the passage, restricting oil flow, which stiffens the compression damping action. Turning the knob in the opposite direction opens the valve and allows the oil to flow freely into the reservoir, softening the compression damping action. Other adjustments that can be made are the spring preload and rebound damping. These adjustments should be made together with the compression damping adjustment. These adjustments will be discussed later in this program. This next section will explain the disassembly and servicing of the new sport fork. A fork tube holder, part number HD-41177, should be used for disassembly to prevent damage to the slider or fork tube. Before the fork is disassembled, the rebound damping force adjuster should be turned counterclockwise to its minimum position. Next, wipe down the fork to remove any debris. Begin the fork disassembly by first removing the stopper ring. Using a 7/8 inch wrench, remove the spring preload adjuster. Loosen the fork cap. Grasp the fork tube and unscrew it from the fork cap. Slide the fork tube down, exposing the spring. Two new tools must be used in order to remove the spring from the fork leg. They are the spring compressing tool, Kent Moore tool number HD-41549, and the spring plate tool, part number HD-41551. The spring collar has two holes, which allow the compressing tool to grip the collar so that the spring can be compressed. Position the tool over the spring collar. Turn the screws on the compressor tool so they engage the holes in the collar. With the help of another technician, compress the spring until it clears the lower end of the rebound adjuster. Place the spring plate tool between the spacer and lock nut. Next, separate the fork cap from the rebound adjuster. Remove the preload adjuster plate from the fork cap. Compress the spring once again and remove the spring plate tool. Next, remove the spacers, spring collar, and spring. Drain the fork fluid by pumping the fork leg and damper rod until the damper rod moves freely. Using an 8mm Allen socket, remove the Allen head bolt. After this bolt is removed, you can now remove the damper cartridge from the slider. Using an alignment drift, gently tap the dust cover from the slider. With a flat-bladed screwdriver, carefully remove the dust seal by prying it off evenly around the lip of the slider. Next, remove the retaining ring. In quick successive motions, pull the fork tube out of the slider. Remove the oil seal, spacer, and guide bushing from the fork tube. Inspect the slide and guide bushings for scratches or excessive wear. If the bushings exhibit any of these, they must be replaced. Next, inspect the tube for scratches or abnormal wear. Check the fork tube. The tube should show a bright, shiny surface where it is contacted by the seal. This area should also be free of scoring and abrasions. The fork tube runout should be checked. Begin by placing the tube on V-blocks. Using a dial indicator, check to see that the runout does not exceed 0.008 of an inch at its center. Place the fork spring on a level surface and measure the spring free length. If the length is less than 16 inches or 407 millimeters, the spring must be replaced. Using fork oil, lubricate the slide and guide bushings. Next, install the guide bushing onto the fork tube. Make sure the slide and guide bushings face the side of the fork tube. Drive the guide bushing into the slider with the fork seal installer, part number HD-36583. Using Type E fork oil, lubricate the new oil seal and install the seal onto the slider. Next, drive the oil seal into the slider with the seal installer. The following procedures must be followed if the rebound adjuster was disassembled for any reason. Locate the detent ball on the adjuster. Hold your thumb on the detent ball and spring. Back out the rebound adjuster fully until it stops. Then turn clockwise until you reach the first click. Then turn the rebound adjuster clockwise, counting 13 clicks. Next, install the rebound adjuster onto the damper rod until it is fully seated. Do not over-tighten. Then thread the lock nut up to the base of the rebound adjuster and tighten. With the slider being held by the fork tube holder, install the damper tube. Install the Allen bolt and torque to between 22 and 29 foot-pounds. Pour half the Type E fork fluid into the fork tube. Pump the damper rod slowly 10 or more times. Then let the damper rod settle to its fully bottomed position. Pour the rest of the fork fluid into the fork tube. Use a pro-level oil gauge to set the right fluid level. Measure 5.6 inches on the shaft of the gauge and lock down the set ring. Using the oil gauge, draw out the fork fluid until it reaches the correct level. Use the help of another technician to hold the damper rod up. Clean and install the spring with the progressive winding facing downwards. Install the spring collar and the spacers with their rough edge facing the collar. Compress the spring, collar, and spacers past the lock nut. Next, place the spring plate between the spacer and lock nut. Install the spring adjuster plate. Replace and lubricate the O-rings on the fork cap and spring preload adjuster. Install the fork cap on the rebound adjuster. Torque to between 22 and 29 foot-pounds. Compress the spring once again and remove the spring plate. Next, remove the spring compression tool. Bring up the slider tube to the cap and tighten to between 11 and 22 foot-pounds torque. Install a retaining ring, being careful not to scratch the slider. Next, install the dust seal and cap using the seal installer. Install the preload adjuster, followed by the stopper ring. This completes the service procedures for the fork legs. They can now be reinstalled into the fork brackets. Please refer to the service manual for reinstallation procedures. The spring preload must be adjusted on the front and rear suspension. This assures that the suspension has the correct amount of travel. This adjustment must be made before any other adjustments are attempted. The correct preload setting will result in a bike that suits the rider's size and weight. Setting this adjustment will require the help of another technician. First, bounce up and down on the bike a few times to be sure the suspension is free and not binding. With the motorcycle unloaded, measure the distance at the rear shock between the upper and lower bolt centers. Next, move to the front fork and measure the distance from the center of the front axle to the bottom of the lower triple clamp. With the help of another technician, take the same measurements with the rider in full gear on the motorcycle. Subtract the second measurement from the first. The difference is called the squat. This number must be in the range of 0.5 to 1.0 inches. If not, the spring preload must be adjusted. The XL 1200S model has 5 preload positions. The setting should be on the off cam or first position for an average weight solo rider. The second or third cam step should be used for a heavier solo rider. If the rider has a passenger, the adjustment should be made to the highest setting. Adjust the shock preload to the desired position using a spanner wrench. The spring adjusting cams on both shock absorbers must be set to the same position. Failure to do this will impair the motorcycle's ability to respond to various road conditions. Next, adjust the front fork spring preload. Turn the spring adjusting nut using a 7/8 inch wrench. Turning the nut clockwise increases preload. Turning it counterclockwise decreases preload. Inscribed lines on the preload adjusters help to ensure that each fork is at the same setting. After the preload has been adjusted, remeasure the front fork and shock absorber squat. Continue adjusting the preload until the suspension falls within the specifications given. After the correct preload is obtained, the compression and rebound damping adjustments can be made. The fork and shock absorber compression damping adjusters each have 14 possible settings. Rotating the knob toward the H increases compression damping, giving a harder setting. Rotating the knob in the S direction yields softer or decreased damping. The rebound damping adjusters work much in the same way as the compression adjusters. The differences are the use of a dial instead of a knob in the lower shock eye casting, and the rebound adjuster on the front fork has a minimum of 12 or 15 positions. Begin by checking the tires for correct pressure. Set all the damping adjustments to the factory recommended settings. These can be found in the owner's manual. Take the bike out and ride it over a variety of surfaces at various speeds. If the suspension needs further adjustment, do it in 1 or 2 click increments. Adjusting more than this may cause you to skip the best possible adjustment. Test ride the vehicle after each adjustment. When an adjustment shows no difference in performance, return to the previous setting. Evaluating and changing the rebound and compression damping is a very subjective process with many variables. If the suspension is set properly, the motorcycle will ride comfortably and have more responsive handling.